Okay, this lesson is on stoichiometry, doing mass-to-mass calculations using the factor label method. Now, we've done stoichiometry calculations using the mole-to-mole method, using the BCA tables, and also the factor label method. This one is just focusing on the factor label method, aka the dimensional analysis method. Okay, mass-to-mass stoichiometry problems are no different than the mole-to-mole stoichiometry problems, except you have to add additional steps on the front end and the back end of the calculation to convert from grams to moles and then moles back into grams. Because remember, as chemists, we weigh stuff in mass in grams, but all the calculations are done on a mole ratio basis. So the first thing we're going to do is always balance our chemical equation. Then we're going to change the given amount in grams to the given amount in moles. Using the molar ratio that we get from our balanced equation, we're going to convert from the given moles to the want or the desired unknown moles. And then we're going to convert that factor back into the grams for the final answer. So basically what it is, you're going from grams to moles, then you use the molar ratio from the balanced equation to convert from one material to another in moles, and then moles back to grams of the final material. Here is a visual of the stoichiometry, quote, mole bridge, as some people call it. But bottom line is, this is a visual to help you understand what we're doing. Now, on this side is what we're given, and on this side is what we want, or the unknown. And then the bridge is the molar ratio bridge from the balanced equation. Now, we are going to start today just using mass of given to convert to moles of given, then to moles of want or unknown, and then back to mass of want or unknown. You could also start with molecules of given, convert that to moles, right? You already know how to do that. Something you haven't had to do yet is with the ideal gas is a new conversion factor. So that way we're not going to worry about that today. So don't worry about this or this, but this is what we're going to be focusing on today, this pathway. But you could take one of these other pathways too to get there, right? But notice the pathway always goes through the molar ratio in the middle. So for today, we're going to go from grams of given to moles of given to moles of want or unknown to grams of want or unknown. And that's what we're going to be focusing on for the next few minutes. Some of you may have looked at that diagram in the previous slide and said, wow, that's pretty complicated, that's pretty intimidating. And it's not. We're just going to show you that the pathway is just built up of 3 individual pieces. And these are the pieces. The first piece is you are going to convert from grams to moles of given. So that's this conversion process here. And you've done that before when we first started doing molar conversions, right? To convert from grams to moles, you've done this process several times. And at the end of the day, when you're done, what do you get? You get this, moles of given. So if you were to do just this math here, you get moles of given. Now, this is the start point. This answer is the start point for your mole-to-mole stoichiometry problems, which you have done before. Remember, I've always given you the moles in the problem. You just calculated it here. So the moles of given now, using the molar ratio from your balanced equation, right? This is from our balanced equation. That gives you the moles of want. So now we've gotten from grams of given to moles of want in 2 calculations. And then again, this is the start point for your next calculation. Moles of want, converting back to grams of want using the molar mass. And at the end of that calculation, you get your grams of want. So there are 3 separate calculations that you could do in series, making sure that you take the answer from each calculation and plugging it in as a start point of the next equation. Now, that's kind of tedious, and it's also kind of inefficient. So we're going to teach you now how to do it all in one step. And basically what we're going to do is we're just going to take each one of these sections and just put them next to each other. So here's our first section, then it's our next section, and then this would be our last section over here. I'll show you that on the next page. Here is the methodology or the process for doing gram-to-gram stoichiometry problems in one continuous calculation. You start, there it is. So I would suggest writing this down in your notebook or notes and showing, putting that as a template. And this is the thing you will follow for every gram-to-gram calculation for stoichiometry on the planet, for any time I ask it, because it's the same. You start out with grams of given, you convert that to moles of given, you convert that to moles of want, you convert that moles of want to back to grams of want. So before we did 3 individual calculations, and then we used the answers from each calculation to the start point of the next one. In this process, we're all doing it all at once. Now to show you that this process is basically the same as the other process, except we've just linked the calculations. This is the first calculation that you would have done, because the answer that you get here is the start of the second calculation, which is this. And then that answer, moles of want, is the start of the third calculation here. Okay? So at the end of this, if you stop the calculation right here, you'd have moles of given. If you stopped it here, you'd have moles of want. If you stopped it here, you get grams of want. So that's all we've done. This was the first calculation we did on the previous page. This is the second one. And then this is the third one. Right? Again, there's no right way or wrong way to do this. Some people feel more comfortable doing it in one continuous setup. Some people would feel more comfortable doing it 3 individual calculations. Whatever works for you. Do it whatever way you want. Right? But I find this way to be more efficient, less prone to errors as far as calculations, right? As long as you set it up correctly. And it's always set up the same way for each problem. So, again, pick the way that works best with you and run with it. We are going to use these 2 problems to help us demonstrate the one-step conversion technique using the factor label method for gram-to-gram stoichiometry problems. So the first problem we're going to work out as best we can, but we're not going to solve it on this page. We'll solve it on the next page. The second problem on here, we're just going to identify all the parameters that we need, and then that will also be solved on the second page because we'll run out of room. All right, so the first thing I'm going to do is underline what I'm given. And so I'm going to read the problem here real quick. If 301 grams of C3H8 combust completely, how many grams of water will be produced? Well, I've got a number and a unit here, 301 grams of something. So there's my given. So that's my given. And then what do I want to find? How many grams of water? So that's my want. So far, so good. Okay, now we're going to set up our picket fence, our factor label method. So we need 4 sections. 1, 2, 3, 4. And remember, what goes in the first box always is the given. So we're going to write (301) grams of C3H8. And that goes over 1. And then it's 1 mole of C3H8. And then what do we got to use there? That's the molar mass. We're not going to look that up right now, but I'm just going to molar mass C3H8. Okay, good. So now at the end of this, we've calculated the number of moles of C3H8. Now we've got to convert it over to moles of water. All right, so we're going to put moles of H2O, and we're converting from what? Moles of C3H8. And then the last thing we've got to do is put 1 mole of H2O, and then the molar mass of H2O. All right, so everything that we got to find out is, well, from here, as we got to look up the molar masses, obviously, but what else do we need to figure this out? Well, we need the mole ratio. And I told you that the mole ratio comes right from your balanced equation. So the 4 goes with the water, and the 1 goes with the CH3 because there's a 1 there, right? So that's set up correctly. And now we just have to finish the calculation. Let's look at the second one here. The second one is 25 grams of oxygen. All right, so that's my given. So we're going to circle that because that's what we're going to be needing later. How many grams of potassium chlorate? So grams of potassium chlorate. So there's my want. And that's this material here. So when we look for our molar ratios, we're going to need the 2 and we're going to need the 3. Right? And we're going to set it up to basically the same way. So let's look at the next page. Here are the answers all spelled out, nicely laid out. And let's just quickly review what each of the picket fence or each of the sections is representing. So the first section here again is the given material in grams that you start with. The second section here is converting that grams of material into moles of that material using the molar mass. So here's the molar mass of each one of the materials. The third section of the picket fence or the factor label method thing is the molar ratio of your wanted material versus your given material. Wanted material versus given material. You get these numbers directly from where? You get them directly from your balanced equation, right? Here's the 4 for the water, and here's the 1 for the C3H8. Here's the 2 for the KClO3, and the 3 for the oxygen. Remember, the balance equation is where you get these numbers here, not anywhere else, right? This number here, the molar mass, you'll have to look up or calculate. And then the last section is converting back to grams using the molar mass of the wanted material. In this case, it's water for here, and it's potassium chlorate here. So you'd have to either calculate that or look that up, and that's always over 1 mole of that material. So when you do the master calculation and you multiply all the numbers on the top to get the big numerator, and then you multiply all the numbers on the bottom to get the large denominator, take that large numerator divided by the large denominator, and you'll get your final answer. So you should have gotten 493 grams for the water and 63.5 grams for the potassium chlorate. Again, all of these are set up exactly the same thing. You can just kind of draw a line. There's a given, convert to moles, molar ratio, convert back to grams. It's that way for each sequence, each process, each problem. Okay, this is the second to last slide in the lesson. Now what I want you to do is, when I tell you to, I want you to stop the video and try the problem. Now I'm going to give you a little bit of helpful advice. When you stop the video, you could rewind it a little bit and look for that slide that had that master template on it and copy that down on a piece of paper, and that'll give you something to start with, right? But all the problems that we've done are using the exact same template. Grams of given, convert to moles of given. From there, you convert to grams of want using the molar ratio from your periodic table. And then finally back into grams of want using the molar ratio of the want material. Excuse me, the molar mass of the want material. So again, same process for all of them. So what I want you to do, and when I tell you to, is stop the video, do the problem, and then restart the video when you are ready to get the answers. So get ready to stop the video now. Hopefully you got 2 grams of oxygen. Now if you didn't, try to figure out where we went wrong, but I'm just going to quickly review, and maybe you can spot your error when you go through the review, if you didn't get it right. If you got it right, then you can basically turn off the video now and do something else. So let's review real quick what we got here. We've got to understand what we were given and what we want. So I was given 11.5 grams of NO2. So again, that goes there. That's my given. And then what do we want to find? Well, we want to find how many grams of oxygen. So this is our want, and eventually that ends up there and also there because those are our want materials, right? Now, the first box here is just our start point, right? It's got nothing there's no calculation here. It's just 11.5 or 1. This box converts the grams of the given to the moles of given. This box here, the 2 numbers come from where? Where do the 2 numbers come from again? Well, the given number, 4, comes right from the balanced equation. And the want number, 1, again, comes from the balanced equation. Remember, there's a 1 in front of the O2. Everything else is you either look it up, O2, molar mass, or you have to, there is no calculation really. Either you look it up or you do a separate calculation for the molar mass, but there's no calculation that you have to do to put a number in here. This is already defined. You can look this up if you really had to on the internet. You could look this up on the internet, and the only thing that you have to figure out is to go up to the equation. So there's no calculation to put into the calculation. And then the last thing you do is just multiply everything on the top, get a number, multiply everything on the bottom, get a number, take the top number divided by the bottom number to get your final answer. Again, everything is done the same. Grams, convert to moles of nu, convert to grams of nu. And that's it. So hopefully this will make sense, and you can just see that it's a series of steps that's all combined into one.